All right, here is the demo video that goes with the texture mapping notes. So here we have a nice map of the world on a cube. Yep, there we go. And let's look at some of the things we can do with it. First of all, let's talk about filtering. This is the linear. Let's do the nearest. And really, because this is a pretty high-res texture, oh, I have to zoom in, but there we go. So you can see that when you do nearest, multiple pixels map to the same texel, and so you get this blockiness. Whereas when you do linear, you're doing that bilinear interpolation, and so each pixel on the screen maps to a different weighted combination of texels in the texture image. So filtering linear, boom, there we go. Looks a lot better. So most of the time we just use linear. And there was a time in graphics hardware history where because the bilinear filtering is taking four corner values and doing a weighted average, that when you switched from nearest to linear, it took exactly 4 times as long for your scene to draw. Well, okay, those days are gone. It now does those four texel lookups in parallel. So there's really no advantage in using nearest unless you really do want that sort of crisp chunkiness instead of that a little bit blurry blending. All right, what else do we have? Let's look at, um, well, let's not do that yet. Okay, so let's look at scaling. So remember, you can't scale the image. You can only scale the texture coordinates, the S and T. So each face on the cube goes from 0, 0 S and T in one corner to 1, 1 S and T in the other. So let me do a 2. And what we get is this. So essentially, we've made each image smaller. We just have more of them. So 0, 0 is still down here because we scaled, and you scale 0, 0, you get 0, 0. 1, 1 was right here. When we scale by, or 1, 1 was right here, rather, upper right corner. When we scale by 2, we get 2, 2 in the upper right corner, which means we duplicate the image. So 1, 1 is now right here. So if we go to scaling, and okay, back to 1. Now if we do scaling 0.5, that means instead of this being 1, 1 up here in this upper right corner, it's going to be 0.5, 0.5. And when we make it 0.5, 0.5, well, we only get the lower left part of the texture image. And if we make the scaling 5, well, then we get 25 worlds, which is how you do bricks in a wall or images on wallpaper, rocks in the wall of a dungeon, and so on. We'll do the same thing with rotation. Okay, I'm going to rotate 45 degrees. If I was rotating the image, that means the image would go this way, okay, like this. However, because we are we're rotating the texture coordinates, not the image, if I do 45, it rotates it backwards. Okay, again, when you're doing transformations like this on texture images, take what you want the image to do and apply the inverse transform of that to the S and T coordinates. So if I go back to 0, I'm here, and if I go to 45 degrees, well, now I've rotated the image plus 45 degrees. So there we go. I'm going to go back to scale, and I'm going to do that 2. And I'm going to change the wrapping behavior to clamp, meaning it takes what's on the edge and duplicates it. Most of the time we do the repeat, so we can get that. And typically we do that even if we don't want it, just so that we can tell if we've accidentally done that in the program. All right, let's do, oh, here we go. All right, so let's change the cube color. Right now the cube color is white. Let's make it green. And oh, it makes no difference. That's because in our texture environment, we're doing replace. Let's change it to no texture. Okay, now we have a green cube and it's lit. So you can see as We rotate it around, different sides become lit up. If I change the texture environment to replace, the green cube, the lit green cube makes no difference. If I change the texture environment to modulate, well, now the green lit cube is shining up through the texture. Okay, and yeah, okay, we're getting it green. If we change the cube color back to white, well, now we have the real texture, only it's lit. That is, the intensity of the white is what's shining up through the texture. And, we can play with this all we want. Oh, let's make red. Well, now we get this. Okay, so, but the real message here is, oops, the real message is hit the right color. Um, Texture environment, replace, just pays no attention to the underlying geometry, just slaps texel colors on it. And modulate lets the underlying color, including any lighting you happen to have, shine up through it. And that's pretty useful. That's pretty useful to do both lighting and texturing at the same time. Okay, so that's sort of everything, all the options in texturing. I wanted to show you some of the things we can do with procedural textures. It's We need shaders to do it. And this is really something we talk about in the shaders class um, a little bit here in this class, but not as much. But here we go. Here is Oregon. It looks like we have a million triangles because we've got heights. We've got, it looked like physical 3D heights. In fact, we don't. This is playing a trick where at every pixel on the screen, it's doing some math on the texture heights and generating lighting information at the pixel. So it's not doing any geometry. This is all one quadrilateral. We can make it look like it's real heights. We can make it higher. We can make it lower. But it's one quadrilateral just doing arithmetic at each pixel in the shader. Okay, but it's computing what the surface normal there would have been. And if we change the light direction, we can get some lighting effects here. It's great. Now, where you pay for this is if you were to fly along it. Well, now we're going to find out it's not real heights. Let's look along it and oh no, this is perfectly flat. Okay. But if you're looking at it from up here, like if you're doing visualization and you want to plot data onto a topo map of Oregon, this is great because it is so fast to display this, way faster than if you had a million 3D triangles. And even on my laptop, I can turn on the frame rate and yeah, we're getting a rate of like 4,000 or 5,000 frames per second here. So very fast, but if you get down along it, you're not fooling anyone. This is known as bump mapping. And again, we talk about this a lot in the shaders class. So this is an example of a procedural texture where you're doing arithmetic, not reading from a file. The other example of this I would like to run is the Mandelbrot set. So here is the Mandelbrot set, and it's doing some complex number arithmetic at every pixel on the screen. And if I start zooming in, it just keeps doing the arithmetic. And what's cool is, this little pattern, I call this pattern a ladybug. No one else calls it that. But that's what you look for. And as we zoom in, well, there's a ladybug, and there's a ladybug, and there's a ladybug, and you just keep zooming in on it. Now, at some point, we start to hit floating point precision, and that's what this is. But if we could keep going, we would find more and more of these blue patterns buried deep inside. But it's computing it. It's not reading it from an image, it's computing it with an equation. So this is another wonderful example of procedural textures. And again, if we turn on the display frame rate, we're getting to 2,000 frames per second here or more. So clearly the shader program is working its little butt off, but it's creating a really nice effect. So anyway, those are two examples of procedural textures. We can talk about them more if you'd like, but really this is the kind of thing we do in the shaders class.